What if you could learn the rules of a game just by watching it, with nobody ever explaining anything to you? Most people imagine AI learning like a student with a teacher. You show it a photo of a cat, you tell it, "That's a cat," and it remembers. That's called supervised learning, and it works well, but it needs a lot of labeled examples. The problem is that labeling data is slow and expensive. Someone has to sit down and manually tag millions of images, sentences, or sounds. For a lot of real-world data, those labels simply don't exist. So researchers asked a different question. Can a model find useful patterns on its own, with no labels at all? That idea is called unsupervised learning. Think about dropping 1,000 marbles on the floor. You didn't tell the marbles where to go, but you'd still notice they naturally form clusters. A pile here, a pile there. A neural network can do something similar with data. One of the simplest unsupervised techniques is called clustering. The model looks at raw data points and tries to group the ones that seem similar together, without anyone defining what similar means up front. The model measures things like how close 2 points are in what's called a feature space. Basically a mathematical map where similar things end up near each other. After enough passes through the data, clear groups start to emerge. Another approach uses a structure called an autoencoder. The model has 2 parts: an encoder that squishes the data down into a tiny compressed summary, and a decoder that tries to rebuild the original data from that summary. Here's the clever part. The model grades itself. It compares what it rebuilt to what it started with, and adjusts until the reconstruction gets as close as possible. No human label needed, just that internal feedback loop. To rebuild the data accurately, the encoder has to learn what actually matters about it, the underlying structure. That compressed middle layer ends up capturing the most meaningful features, almost by accident. A related technique called dimensionality reduction takes high-dimensional data, imagine data with hundreds of variables, and maps it down to 2 or 3 dimensions so you can actually see the shape of it. When researchers do this with something like a merged set of news articles, articles about sports end up in one region, articles about politics in another, and science articles somewhere else, even though nobody told the model those categories existed. This is why unsupervised learning matters so much right now. The internet is full of raw, unlabeled text, images, and audio. Models that can learn from that without needing human annotation can train on a scale that would otherwise be impossible. Many of the large language models you've heard about were pre-trained using ideas rooted in unsupervised learning, finding patterns in enormous amounts of text before anyone fine-tuned them for a specific task. The surprising thing is that structure is hiding in almost every dataset, waiting to be found. You don't always need to tell a model the answer. Sometimes you just need to give it enough data and let it look. If you're curious how these unsupervised techniques connect to the AI deploy tools you use every day, that thread goes pretty deep. There's a lot more to explore.